Okay, and we took a look at, we did kind of a basic overview of Spring. We just took a look at some code there and to give you an idea of how Spring Framework's working during that lab. So I'm going to talk briefly about some of the principles here. Actually, not so briefly, because this is important. One of the key principles of Spring is that J2EE, or JEE as it's called now, should be easier to use. This is a key tenet from the book J2EE Development Without J2EE by Rod Johnson. If you think about that for a second, it's kind of an oxymoron, but what it means is that, frankly, J2EE is awfully difficult to use. It should be simpler. And Rod Johnson actually wrote this seminal book. He was supposed to write a JEE book for rocks, and he ended up writing about 300 pages about everything that was wrong with JEE and why it was so difficult. If you were really good at JEE and you read it, you realized that that he was an expert in JEE. He found every flaw and hole with it. And the second part of the book, he introduced this new framework called Spring. And basically, Spring was the answer to all of the hypercomplexity and difficulty in the JEE environment. It made everything simple. And JEE should be easier to use, both from a, you should be able to consume JEE resources easier, and also just plain doing enterprise Java development should be simpler. And that's why he created Spring, and it is simpler in Spring. Another key principle here is that it's best to program to interfaces rather than classes. So you should be programming to a Java interface rather than to a Java, particular Java class implementation. Because by coding to the interface, you allow flexibility around the implementation later. In other words, if the calling code only uses the interface, in other words, casts this object to the interface, then I could provide 3 or 4 or 5 or swap out the implementations as long as they all match the interface. Great, we can improve the implementation. We could change our security framework backing from being an XML config file with name value pairs and usernames and passwords to a database or to an LDAP store. We can just swap out the implementation classes, and the calling code doesn't know the difference because it's using the interface. So Spring reduces the complexity cost of using interfaces to near zero because of the way the beans are wired into the container. Also, Java Beans offers a great way for configuring applications. When you're configuring apps, we're always setting properties, setting a JDBC username and a JDBC password and a JDBC URL. It's over and over and over again. Beans are a great way to do this, and Spring essentially leverages the Java Beans framework and provides a way to do configuration that is persistible outside of the Java container as files, and yet can immediately be pulled up and pushed into Java Beans in the runtime. Another key Spring principle here, OO design is more important than any implementation technology such as J2EE. If you've been around JEE in development for a while, you know that there are things we do that are not actually, we don't follow OO principles. We separate data from behavior all the time, which is the fundamental of OO design. We're required to do it by entity beans to separate into data transfer objects. It's just, in this case, what the principle is saying is that good design will actually, so there's that JEE should not force us to use bad OO design, but the converse is true. Really good OO design is actually more important than having a great JEE app server. With better design, you can run in a smaller, lighter, faster container like Spring. So that's another principle there. It's kind of a double-edged one. There's another principle here that that checked exceptions are overused in Java, and this is not just Spring. This is Spring. This is Hibernate. Many of the contemporary frameworks and tool sets that we're using are kind of moving into a place where they throw runtime exceptions a lot more, things that are unchecked. And the point here is that a framework shouldn't force you to catch exceptions that you are unlikely to be able to recover from. In other words, don't make every exception a checked exception, an exception that the compiler will check and make me do a try catch finally for that exception. If I catch some exception like I can't connect to the database, okay, maybe I could retry, but it's probably a catastrophic failure. I mean, I can't do anything about it. My app really can't work without the database connection. So what am I going to do about it? Don't make it a checked exception. Let it be a runtime exception. That's the reasoning. And Hibernate has actually been doing this for quite a while now. And Spring is, again, part of this. And it does require some changes in your programming methodology, in the way you code. But this is one of the kind of key principles around Spring. Another key principle I almost believe is maybe the key principle around Spring is that testability is essential. And that Spring or any framework should make your code easier to test. This is a dig at JEE EJBs, which are notoriously difficult to test because you must build and deploy them into a container, an EJB container of some kind, in order to invoke them properly. So you can't test them without building them and deploying, and that makes testing, harder, frankly. The other piece here is that Spring, by enabling certain programming paradigms that we'll talk about later, really enhance the testability of your app also by encouraging you to code to the interfaces. That enhances the testability. It's a lot easier to swap out and use mock objects like EasyMock or something like that, or a database mocking tool to allow you to test your code. Also, part of just the way you code in Spring tends to lead you down the way of better OO design, which then leads you to better testability. And again, on that easier to test, I'll put it this way: improved cycle time equals improved productivity. Every time a developer needs to build and deploy, and then push that code into a container, and deploy it into a container, in order to test anything, that's kind of wasted time. And with Spring, you don't have to do that because you can write that code in Spring. You can initialize Spring in JUnit, fire up the Spring container, test all the code inside. Short, easy cycle. It reduces the cycle time, which buys time for developers, which of course we can use for improved productivity, or we can use to play Doom on the corporate network. But either way, improved cycle time is a good thing. So we've all taken a look at different containers. Obviously, there was, this group was in a course yesterday around the new EE containers and JE6. But the key thing to think about with a container, be it a web container, an application client container, or an EJB container, is that containers contain code that we write, and we have to agree to the contract of that container. Part of containers, especially JEE containers, is the contract is kind of restrictive. I mean, think about it. If you code a servlet, you have to extend JavaX servlet. And that class, that might not work the same way if you're outside the container. EJB certainly does not run the same way and is not instantiable and runnable in the same manner outside of the container. So that container contract by the JEE servers is relatively strict. In Spring, the contract is extremely lax. All you need to do is be a Java object, and you do need to expose. You have to be a Java bean if you want to have configuration set into you or dependencies set into that bean. So the container contract is significantly looser and significantly just more friendly and frankly lighter in Spring compared to JEE containers. That's part of it's a point Rod Johnson made in his book too. Absolutely. Also, given the fact when you're looking at these containers, Spring is a container. It is a container. It's a thing that you configure and deploy code in, and that you bring up as a runtime, and your code executes inside of it. So Spring's a container just like the web container or the EJB container for that matter. So one of the things I like to talk about with developers, because some of us can be really, really concrete in our learning, is what do I need to use to use Spring? What do I have to have? What are the pieces I need? So there's pretty easy. Fundamentally, there's 5 key pieces that you have to have in order to build the Spring app. Well, first, you need to have an external application that's going to actually fire up the Spring container and call into it and use the code in there. Spring isn't meant to run by itself. It's something that some code uses. It's a library that provides a container. Now, of note, many web containers are actually easily configurable to instantiate Spring and execute Spring and actually delegate web requests into Spring. This happens all the time when we're hosting web services in Spring, etc. Almost always we're hosting web services in Spring inside a JEE web container. So it makes sense that in the web container, specifically normally in the web XML of that web app, there's configuration you use. It's pretty short and simple to initialize Spring and bind Spring in, so that when you bind Spring in to a web container, Spring attaches it. Spring binds and it's able to basically accept web requests. So that's one thing you need. You need an app to actually fire up and call into Spring. The second thing you need is you need Java classes that are Java beans with no arg constructors to actually put into Spring. Spring, if you bring up a Spring container by itself, it doesn't do anything because it's just a Spring container. It's meant to hold our code that we craft and write to accomplish business goals and do things like accessing databases or writing messages to queues or applying business logic, and that's we have to build the behavior that we want into classes in the beans so that we can put them into Spring. So that's the second thing you need. The third thing you need to use Spring is either a bean factory or an application context. Now, to be fair, an application context has a bean factory. So the way to think of this is that bean factory is kind of a bare bones. It's a bare bones Spring implementation that will initiate. It can read a Spring config file and can create beans. That's what a bean factory does. Now, an application context can do much more than that. An application context contains a bean factory, so you get everything that you have with a bean factory with an application context. However, an application context can participate in the Java lifecycle. Like for a VM, it can handle lifecycle events like shutdown, out of memory, things like that. An application context can provide additional facilities and services to the beans inside of it that a bean factory can't. And an application context also typically expose and are hooked into, for example, typically a JEE web container like a Tomcat or the web container inside WebLogic will consume an application context and use an application context to initialize its Spring instance, because the application context offers some better external hooks too for the web container to use. So there's not a whole lot of performance difference anymore between these. I mean, a bean factory will use a little bit less memory and is a little smaller. So I mean, if you were coding for like a mobile device or something, you could run on a bean factory and try and be a little leaner. But for the most part, almost always, you're actually going to use some subclass of application context, like ClassPath, XML application context, or file system application context, or AppConfig application context. There's about, I don't know, maybe 20 or 30 of these application context instances that are implementations that are available with the Spring library. So you need an application context as a way to pull everything up and actually start Spring. Now, you also need an XML configuration file. The XML configuration file is consumed by the application context on startup and tells the application context either directly or indirectly where the beans are and what beans should be in the context and how they should be loaded and what kind of bean they should be. And sometimes metadata about those beans and what are the relationships between those beans. That's all either directly in the XML configuration file or it's available because of facilities brought up by the XML configuration file. We'll talk more about this later, but you must have an XML configuration file at a bare minimum to initialize and use Spring. Last, Spring libraries. Well, yes, okay, that kind of makes sense. You have to have those Spring libraries in order to use Spring. More importantly, this is not just the Spring.jar anymore. For a long time, Spring was pretty simple and everything was in one jar. It was great. And you could just use the Spring jar. This was kind of like back in the days of WebLogic where there was just the WebLogic jar and everything was in there and that's all we need to worry about. Recently that's changed. As of 2.5, Spring 2.5, we're now on Spring 3.0. The jars were split. And now, essentially, the way it feels is whenever you want to do something new and interesting in Spring or use some new Spring facility, there's a new jar you need. They've just modularized their jars down significantly, and those jars, it's just easier for open source projects to maintain a smaller jar and that kind of thing. But so those Spring libraries you will be bringing in 10, 15, 20 Spring jars, not uncommon at all. So what you need to use Spring, what are the parts? You need an external application to actually initialize, to call in and fire up Spring and use it to do something. You need classes to actually do the work and encapsulate your behavior you want. You need a bean factory or an application context in order to initialize Spring with, that is the Spring loader and initializer. You need an XML configuration file, and you need the Spring libraries. So, I'm going to talk briefly about configuration of Spring because this is kind of key. Obviously, when we're doing configuration, what we're doing is we're declaring the beans and resources that need to be bound into the Spring context. We're declaring them one way or another. Okay? There are multiple ways to configure things in Spring. This is one of the key pieces, though, obviously, how you declare these things. Where should they be acquired from? How is Spring going to find them? In what order should they be initialized in? Is there a priority about how they're initialized? That's all in in the Spring configuration. Now, currently there are 3 major ways to do Spring configuration. The first one is the classic, the XML configuration file. Do not confuse this. We have to have a configuration file with some basic information in it in order that is configuration of the Spring container itself. But you can also configure all the beans in the XML configuration file directly. This is the classic way. This is how Spring launched, and it is 100% still supported by Spring. It tends to produce very large XML files and sometimes intricately related XML files if you're using multiple XML files in one Spring container. But more importantly, it seems to be falling out of usage because of Java annotations. The whole Java world is kind of moving to annotations. And these are annotations like @entityBean or @sign bean or @sign_value. These are Java annotations inlined in the code in the Java source files. Most of the Java universe is just moving and using annotations for things. We've been using annotations in Hibernate and JPA for a long time now. Spring has supported them, but they're really the mainstream way to do Spring configuration of beans now. You still do need the XML config file in order to tell Spring how to find those annotations and how to interpret them. Last but not least is Java-based configuration. This is a little newcomer. on the field. This was available in Java 2.5, excuse me, in Spring 2.5, and seems to be more mainlined and more mainstreamed in Java 3.0. What I mean by this is the Spring community will often have features. They'll have a new feature like they did in 2.5, this Java-based configuration, but they don't really publicize it. They don't push it around. It's available if you kind of go look for it. And then they let it bake for a major release, and then it becomes part of the core framework, and they start modifying their Java. You'll start seeing like a bunch of Java doc core Spring stuff using this, whatever that new technology is. They'll start updating the docs, adding to the docs, things like that. They'll headline it in the what's changed in 3.0 or what's changed in 3.5, that kind of thing. And that happened this time in Java 3.0, the Java-based, excuse me, in Spring 3.0, the Java-based configuration kind of got headlined. And it's just another way to use an actual Java file to do the configuration. So let's take a look at these three different configuration modalities. First, the classic XML Style config file. You'll notice the classic part that I'm referring to here is there's a bean. This is you actually declaring your beans, a particular class, and then a bean gets an ID. The ID of a bean is how you look it up in the container. That's the key. Think of it that way. And multiple properties. Here you'll notice a property that's a string value, Buenos dias. This property tag means that Spring will initialize the greeting service impl class. We'll call the constructor, get that done. Then for each property in the XML configuration file, it will call the corresponding setter. So in this case, it will call setGreeting with a string value of Buenos dias. Now, there's another property here, and that property is called languages. And notice that that is not a value, that is a ref. This means that the next that Spring is going to want to call the setter set languages on the greeting service impl class that it's instantiated an instance of, but it's going to use a reference to another bean or another resource inside the Spring context. In this case, it's referring to language map, which if you look down, language map is more or less a hash map of key value pairs, and the keys and the values are strings. So we have a dependency here. Spring has the capability to understand that this reference in greeting service impl initialization, that it needs to immediately turn around and initialize that language map, get the language map initialized, and then get a Java reference to that language map and pass it in the setter for set languages on the greeting service impl. Okay? Spring can figure this out, and it will initialize as it needs. And it will figure out, you do not have to order things in a particular order in the file in order to try and make sure that all of your, in this case, language map would need to be before greeting service. That's not how Spring works. So, also in the classic XML file, you will notice with a little bit of overlap here, there's a properties, a util properties tag here, and you'll notice it's called greeting properties. That's the ID, right? And the location. Now this is a location. Here we are pulling a resource, in this case a properties file in, and that properties file was on the class path. That's what the class path colon means. Pulling a properties file in, pulling it up into a Java util properties object, and it's bound into the Spring context, and it's available to other beans to use. Now, that is the configuration variance of wiring beans and resources into Spring. You always have to have an XML configuration file to declare the namespaces and schemas of, the namespaces and corresponding schemas of the various Spring libraries that you want to use. Specifically if you're using tags in here, for example, you'll notice that we have the Spring util namespace right here. And then that is also pulled in here and here, 3 places. That brings in the util namespace, which we then can use for util map and util properties. This is analogous to an import. The XML namespacing is analogous to a Java import statement for an XML document. So if we want to use, and we have another one obviously for context here. If you want to, I removed that for brevity. For the other thing that we'll see inside the Spring config files, whether we configure beans in here or not, are things like context component scan or context annotation config. Those pieces are probably going to be there whether you configure beans or not. These are pieces that are configuring the behavior of Spring itself, not configuring beans. You're configuring how Spring initializes. So that's the XML style configuration of beans, and also the standard XML config that's required for Spring Container to run. Now, configuration using annotations. So earlier I mentioned that Java annotations is kind of taking over the Java world. So you still have to have some XML file. I know I keep saying that, but these 2 tags actually are what enable annotations to work inside Spring. So you have to tell Spring, hey, we want to use annotations. This is how you do that. Of note is that the context component scan tag tells Spring to go search for beans that are identified as components, either at component or at resource or at service. So in this case, you can actually put an attribute in the Java, and you do not need to configure the bean in the config file at all. We're telling Spring to go search the class path for Java classes that are in that base package or below that base package, any sub-packages of hello, and it will go find them and bring them in as beans. Now, lots of annotations. Here's the service annotation. And you're just saying, this is a service, make it into a bean for me. Auto-wired. Auto-wired, we're going to see auto-wired later in the labs, but essentially what auto-wired means is go find, auto-wired is a dependency. So when the class with the auto-wired, with a member in it that's tagged with auto-wired is being initialized, Spring scans it, finds the auto-wired tag, and then immediately goes, looks at the name of that member variable, which in this case somehow disappeared. The name of that member variable will the name of the member variable here, which is notification stack. It will then immediately turn around and search for a bean of the ID notification stack and of the type notification stack. If it finds one, it will set it into this property on whatever class that is that it's in. You can do this. You can use auto-wired for properties or private, member variables themselves. It's just a simpler way so there's very little config. All you're doing is say, this field is auto-wired. Go get it out of context. Another big tag is resource. And a resource is things that aren't beans. Usually resources are the most commonly used one is a property file. Sometimes it's a data source. Resources can be a lot of different things. But the @resource tags identifies this thing as a resource to the container. So that's the annotation style, and we'll see this in the labs. There's one more. There is a configuration using Java style. Now, Java style configuration. In this case, yes, you still need an XML config file, but like the annotation style, the Java style XML config file will be a lot thinner because there's really not a lot of beans in there. What you have then is with Java style, you have a Java class with the configuration coded in. So in this case, this class is called appconfig. That's a kind of a standard at this point. And it's got the app configuration attribute on it. that identifies this class as a configuration class to the Spring container. This naming of app config is a new convention. They're moving more towards coding by convention than coding by configuration in Spring. So they're usually called app config. That's all the examples I see seem to be using that. And then you just have, in this case, you have properties. They're declared as variables with the @value attribute, and then a Spring expression in there to basically go evaluate against the property bundle that is the current property bundle and get a property out, in this case JDBC properties.url, and then it'll just get, that value will get set into that member variable of this configuration class. The other two methods you're seeing are essentially factory methods. They're attributed as @bean, but what this is saying is this is declaring a bean of type greeting service. There's another one of type data source. It's declaring a bean, and it's just a factory method, basically. So in this case, by default, the bean name will be the name of the method, the name of the factory method. You can, of course, alter that tag so that it gives a name. Now, so that is the three different kinds of configuration that are available in Java right now: classic XML, annotations, and Java style. So now we're going to just, this slide is somehow backwards. We're going to do the lab right here around, we're going to do the Hello World lab, the first part. And I got these slides switched, I apologize. We're going to do the Hello World lab right now, and then when we come back, we'll talk briefly about what happened during the lab.
Thank you. Please stand by.